Hi, this is a podcast from Zimmer and Peacock. It's also a vlog from Zimmer and Peacock for the week starting the 24th of August 2020. So every week we like to do a kind of quick summary of some of the highlights of the week from Zimmer and Peacock. It's kind of really a sort of a form of a newsletter, an audio and visual newsletter if you're following along on the video. So this week we've put out some information regarding measuring the osmolarity in tear film. So some people unfortunately have a condition called dry eye. I imagine from the name of it, it feels like literally the eye is potentially dry. And one way of diagnosing this this problem is through the osmolarity in the tear film. So we put out some notes on that where we talked about sort of the osmolarity that you can expect for, let's say, normal eye, and the osmolarity that you can expect from severe eye, severe problems. And it's kind of quite interesting actually, because the osmolarity, we help define what osmolarity is, and we help define how to actually measure it. We also put a bit of a video out about it. But it's kind of interesting that just going from 300 osmolarity to 340, which is a kind of change of approximately 10%, does lead to from normal to severe. So it's quite a rapid change with just a small change in osmolarity. And at Zimmer and Peacock, because we make electrochemical sensors and we're very good at electrochemistry in general, and we've even done big webinars on techniques like impedance spectroscopy and conductance measurements, we've kind of tried to put that together a little bit on a page to help people navigate this and to demonstrate some of the technologies that we have in place to allow people to quickly sort of get products into that kind of arena. So something else that we talked about, as I say, was actually measuring conductivity with screen printed electrodes. So that's really linked to the whole osmolarity thing that but osmolarity in the eye. If you want osmolarity, you can calculate it by measuring conductivity. And if you want to measure conductivity, then screen printed electrodes are a good platform for doing that. And so we also put some notes down around screen printed electrodes, how they can be used to measure conductivity. And as I say, there's also a note up on the website now about osmolarity as well. It's worth saying that we're also going to be talking at Sensors in Medicine 2020. So unfortunately, we are still in this COVID-19 situation, and Sensors in Medicine is having an online conference, and so Zimmer and Peacock will be talking at that, and we'll be talking in the wearables section. The plan at the moment is actually to have a live demonstration in the middle of that wearables conference, and we'll possibly do have one of our guys on an exercise bike, probably have Andre, one of our guys on an exercise bike, will measure the lactate in his sweat during the conference. So that will be online. So maybe sign up for that conference. It could be fun. We're also, at Zimmer and Peacock, I'm really promoting the idea now of using machine learning in biosensor development. Now at Zimmer and Peacock, we are very well known for making biosensors, but we're really getting into machine learning as well. I think it really makes a big difference when you're developing a biosensor to bring in machine learning strategies and tactics. So we do have some pages around the use of machine learning in biosensor development, and I would encourage any entrepreneurs out there who are interested in working with Zimmer and Peacock, come to us for the biosensing, but also come for us for the data analysis and the algorithm development as well. And as I say, I'm very pleased with the progress that we're making using machine learning on some of the sensor programs. Now this is something I'm very passionate about, which is actually measuring pharmaceutical molecules, APIs, active pharmaceutical ingredients. Now this partly comes from beginning of my career. I actually worked at a company called GSK, GlaxoSmithKline, which was known as Glaxo at one point in its history. It became Glaxo Wellcome, and nowadays it's known as GSK. And there I was actually developing pharmaceutical drugs. And so I really like the marriage of electrochemistry and pharmaceutical drugs. And I think I'm not going to, if you go on our website or Google detecting pharmaceutical API by electrochemistry, hopefully you'll find something related to that. But I'm basically just saying that you can actually detect pharmaceutical molecules using electrochemistry. It's not commonly used, but actually most pharmaceutical drugs are electrochemically active. And so if you're looking for a robust, low-cost technique for measuring the amount of either drug in the blood, drug in the urine, drug in wastewater, or just drug during, let's say, manufacturing itself, then electrochemistry is a good technique. And we show people how to sort of get going using electrochemistry for measuring these kind of drugs. So we have some buttons there that might be kind of interesting. So we did actually have quite a busy week. CBD is a form of THF. So THF is itself tetrahydrofuran. No, I mean THC. THC is the active in illicit drugs like marijuana, but CBD is a derivative of THC, and it is legal and it's used in products for things like pain relief. So our sister company Alixia is really good at analytical chemistry. It owns an HPLC, and we use HPLC for the analysis of products which contain CBD. So if you're interested, I mean, these days it's legal to grow CBD in countries like Portugal, for example, I think in Spain. So we're receiving products from the growers, and we are testing them for the CBD content. So that might be interesting to some people. We have a really good, I'm very passionate about our ZP Developer Zone. And this week we spoke about halal sensors, and I really like it because we're strong in the UK, and we're strong in the USA, and we're strong in Europe, and we're strong in Southeast Asia, and we're particularly strong in Indonesia. So it was nice to see that actually Indonesia is one of the leaders in R&D development of halal sensors. So we did a webinar about that this week, and so if you sort of Google ZP and halal sensors, then there'll be a link to that. We do reference the development that's going on in Indonesia around that technology. We are sponsoring Sensors in Medicine. So I said earlier on that we're talking about Sensors in Medicine. We are also sponsoring the conference as well. And also our sister company Alixia is putting out a new kit for biosensor developers. Alixia is a sister company of ours. They're based in Wolverhampton. They're really good at biology meets electrochemistry. So take a look at Alixia. Maybe follow them on LinkedIn and watch their updates. Something as well, we live in unusual times at the moment. Unfortunately, as this webinar goes out, we are still in the COVID-19 crisis, which is a bit of a shame because there's a lot of people who'd like to come to ZP and do internships, and we'd like to have them. I mean, we like people who are enthusiastic and willing to kind of get on a plane and fly to another country just to get some work experience. Unfortunately, that can't happen quite so readily at the moment. So we are saying, look, if you're in the UK or in Norway, it's easier to do an internship with us. Unfortunately, if you're not in those countries, then maybe you have to do an internship with us online. But we are saying, look, we are open to internships. And then finally, we do a lot of innovation at ZP. We do a lot of new product launches. And so we've done a video about crossing two chasms from getting from academic research to early majority buyers of products. And we talk about the hazards or the pitfalls or the chasms on getting from academic research to the early majority of customers. And so we put a video out about that. So we hope that's interesting. So that's really a summary of the news that ZP put out for the week starting the 24th of August. I hope we're a super friendly company, so if you've got any questions around sensing, biosensing, and contract development and manufacturing, please feel free to reach out to us. Otherwise, please subscribe. We'll do another one next week. Okay, take care. Bye-bye.